Good morning. So in the last class, dehydration of alcohol is completed. So ethyl alcohol reacts with concentrated sulfuric acid. Here, what are the dehydrating agents? Sulfuric acid is the powerful dehydrating agent. H2SO4. Next, second one, phosphoric acid is also used as a dehydrating agent. H3PO4. Next one, phosphorus pentoxide, P2O5, and alumina, Al2O3. It is a mild dehydrating agent. Okay, so sulfuric acid, phosphoric acid, phosphorus pentoxide, aluminum oxide, these are dehydrating agents. Okay, so ethyl alcohol. So this dehydration order is, so dehydration of alcohols order. Dehydration of alcohols order. Tertiary alcohols undergo dehydration easily than secondary alcohols than primary alcohols. Because of tertiary alcohol can form tertiary carbocation. It is more stable. Secondary alcohol can form secondary carbocation. Primary alcohol can form. So it forms a primary carbocation. So tertiary carbocation is more stable. It is the stability order. It is the stability order. So tertiary carbocation is more stable than secondary carbocation is more stable than primary carbocation. So tertiary alcohol can form tertiary alcohol can form tertiary carbocation easily. Secondary alcohol can form secondary carbocation. Primary alcohol can form primary carbocation. Hence, the dehydration reactivity order. So each undergoes dehydration easily. Tertiary alcohols because in the second step tertiary carbocation is formed. In the last class, mechanism is also completed. Here, the product formed depends on temperature. So ethyl alcohol reacts with concentrated sulfuric acid. Concentrated sulfuric acid heating with concentrated sulfuric acid. So here it forms different products. The products are formed depends on temperature. So at 100 degrees centigrade temperature, so low to high temperature. At 140 degrees centigrade temperature, at 170 degrees centigrade temperature. So here the product formed depends on temperature. At 100 degrees centigrade temperature, it forms ethyl hydrogen sulfate, CH3, CH2, HSO4. Next, at 140 degrees centigrade temperature, if you take excess of alcohol, means 2 moles of it required 2 moles of alcohol. So it gives CH3, CH2, it is O, CH2, CH3. So it is a dehydration reaction. It is a dehydration reaction. It is also dehydration reaction at 170 degrees centigrade temperature. It gives ethylene. CH2 double bond CH2. Okay. So sulfuric acid is the dehydrating agent. It is a powerful or strong dehydrating agent. At 100 degrees centigrade, ethyl hydrogen sulfate. At 140 degrees centigrade, alcohol is excess. It gives diethyl ether. At 170 degrees centigrade, it gives ethylene. Okay. So in the last class, up to this property completed. Next one, reactivity order is very important. The next one, if we use other dehydrating agents like phosphoric acid. Another example, phosphoric acid. Okay. So here reactivity order. So what is the reactivity order of different alcohols? Reactivity order. So reactivity order of alcohols. Reactivity order of alcohols is tertiary alcohols are more reactive towards dehydration reaction than secondary alcohols than primary alcohols. Okay. Here, if you take primary alcohol, that is ethyl alcohol, so it is considered as a primary alcohol. If we take primary alcohol, Primary alcohol. So this primary alcohol undergoes dehydration in the presence of sulfuric acid. It required, primary alcohol required 95% of sulfuric acid and 170 degrees centigrade temperature is required. To undergo dehydration, primary alcohol required 95% of sulfuric acid and 170 degrees centigrade to undergo dehydration. Whereas secondary alcohol, so primary alcohol and secondary alcohol, which is more reactive, secondary alcohol. So secondary alcohol required 75% of sulfuric acid H2SO4. And the temperature, so primary alcohol is less reactive, hence it required 170 degrees centigrade and 95% sulfuric acid. Here 75% sulfuric acid, 100 degrees centigrade temperature is enough. Because of secondary alcohol is more reactive than primary alcohol. If you take tertiary alcohol is more reactive towards dehydration. So here just 5% of sulfuric acid is enough. 5%. Just 5% of sulfuric acid is enough. Next temperature 50 degrees centigrade. So it undergoes dehydration. So primary alcohol is required 95% sulfuric acid and high temperature 170. Whereas the secondary alcohol is required 75% of sulfuric acid, just 100 degrees centigrade. Tertiary alcohol is required just 5% of sulfuric acid, means it contains 95% of water, very dilute. So 5% of sulfuric acid and it requires 50 degrees centigrade. So it is a dehydration order. So it is the evidence for reactivity order of primary, secondary, and tertiary alcohols towards dehydration, towards dehydration reaction. Okay. So tertiary alcohols are more reactive because of tertiary alcohol can form tertiary carbocation. So it required 5% of sulfuric acid and 50 degrees centigrade because of this more reactive. Secondary alcohol required 75% of sulfuric acid and 100 degrees centigrade, double the temperature. Okay, because of it is less reactive than tertiary alcohol. Whereas primary alcohol required 95% of sulfuric acid and 170 degrees centigrade. So it indicates the reactivity order of tertiary, secondary, and primary. Primary to secondary reactivity increases. Secondary to tertiary reactivity increases. Okay, na? So like chlorobenzene. So chlorobenzene reacts with chlorobenzene. Chlorobenzene is reacts with NaOH. Cl is replaced by OH. As the electron withdrawing groups increases, so reactivity increases. Nitro, one nitro, dinitro, trinitro. So as the number of nitro groups increases, reactivity of chlorobenzene increases. Here also same, primary to secondary, secondary to tertiary, reactivity increases. It is the evidence. Next one, instead of sulfuric acid, here we also use phosphoric acid. Phosphoric acid is also acts as dehydrating agent. Phosphoric acid is also dehydrating agent. So if you take a secondary alcohol, so to undergo dehydration, so this secondary alcohol required 85% of phosphoric acid. 85% of phosphoric acid. Primary alcohol required 100% of phosphoric acid and high temperature. So it required 170 degrees centigrade. Secondary alcohol. So if phosphoric acid used as a dehydrating agent instead of sulfuric acid, so it is a less dehydrating nature. It has a less dehydrating nature. So secondary alcohol required 85% of phosphoric acid and 170 degrees centigrade temperature is required. If you take tertiary alcohol. So to undergo dehydration, tertiary alcohol required 20% of phosphoric acid, H3PO4. So 85%, 20% because of tertiary alcohol is more reactive than primary alcohol. So here the temperature required is nearly half of the temperature, 85 degrees centigrade. Here, so 75% of sulfuric acid secondary alcohol required 100 degrees centigrade, whereas the tertiary alcohol required 50, means half of the temperature. Here 170 degrees centigrade. Here 85 degrees centigrade, so half of the temperature. Okay, so to convert the Kelvin, add 273. 170 plus 273. Okay, next 85 plus 270. So to convert the Kelvin, add 273. So secondary alcohol required 85% of phosphoric acid, whereas tertiary alcohol required 20% of phosphoric acid. So secondary alcohol required more temperature than tertiary alcohol. So these are the evidences for reactivity of tertiary, secondary, and primary alcohols towards dehydration reaction. So tertiary alcohols undergo dehydration easily than primary alcohol, secondary alcohols undergo dehydration easily than primary alcohol. Commonly we use sulfuric acid, next to phosphoric acid, or alumina is also used as a dehydrating agent. Okay. If we use aluminum oxide, Al2O3, so the product formed is and the temperature required. Example, take ethyl alcohol. It is the primary alcohol. So this ethyl alcohol is heating with alumina. That is aluminum oxide. Aluminum oxide is formula Al2O3. It is dehydrating agent. Treated with or heating with alumina Al2O3. Okay. So here at different temperatures it forms different products. Here first case, here about nearly 250 degrees centigrade, 250 to 260 degrees centigrade. So at about 250 degrees centigrade on Kelvin, here it is about 360 degrees centigrade. Plus or minus 10 means 240 to 260. It is considered as 350 to 370. 350 to 370. So plus or minus 10, it gives the same product. So at 250 degrees centigrade, 250 degrees centigrade means in Kelvin, add 273. It is 3. Next to it is 12. So it is 523 Kelvin. In Kelvin, 523 Kelvin. Next, the second one, 350 degrees centigrade. Add 273. So it is 3, is 12, 623. Okay, so difference is nearly 1. So 523, next one, it is the 623 Kelvin. So to convert the Kelvin, add just 270. So at about 250 degrees centigrade temperature, the product formed is about 350 to 360 degrees centigrade temperature. Here the product formed is 250 to 260, 350 to 360. So here plus or minus 10, nearly 250 to 260. So here we take higher temperature 260. Here 350 to 360. So here nearly 350 to 360 degrees. So it is 260, it is 350. So at 260 degrees centigrade temperature, it forms diethyl ether, C2H5O, C2H5. It will cover in the next chapter, next topic, that is ethers. It is the method of preparation of ether. Ethyl alcohol on heating with alumina at 350 degrees centigrade temperature indicates ethylene, CH2 double bond CH2. It is diethyl ether, it is ethylene. Okay, so here the product formed depends on temperature. So with alumina Al2O3 at 260 degrees centigrade temperature it gives diethyl ether. With alumina at 350 degrees centigrade temperature it gives ethylene. So these are dehydration reactions. So what are the dehydrating agents? Sulfuric acid or phosphoric acid or alumina used as a dehydrating agent. So alumina is also dehydrating agent. In this reaction, 2 moles of ethyl alcohol loses 1 water molecule is diethyl ether. Here 1 mole of ethyl alcohol loses 1 mole of water. 1 mole of water. So it is ethylene. So these are the dehydration reactions of alcohol. So towards dehydration, which type of alcohol is more reactive? Tertiary alcohol is more reactive because of it can form more stable tertiary carbocation. The next reactivity is more for secondary alcohols. The next primary alcohols. Okay, so these are the common dehydrating agents: sulfuric acid, phosphoric acid. The next phosphoric acid. Next alumina. Okay, so here with the sulfuric acid and alumina, these two are important. So ethyl alcohol CH3, CH2, OH ethyl alcohol is treated with concentrated sulfuric acid H2SO4 at 100 degrees centigrade. It gives A. With the sulfuric acid at 140 degrees centigrade, it gives B. With the sulfuric acid H2SO4 at 170 degrees centigrade, it forms C. Next one. Same ethyl alcohol C2H5OH is treated with alumina. Al2O3 at 260 degrees centigrade, it forms X. Next one. Body heating with alumina at about 350 degrees centigrade, it forms Y. So what are A, B, C and X and Y? Okay. So what is X? Ethyl hydrogen sulfate C2H5HSO4. What is B? At 140 degrees centigrade, it forms diethyl ether C2H5O, C2H5 diethyl ether. What is C? C is ethylene CH2 double bond CH2. With alumina, what is X? Here X is diethyl ether C2H5O, C2H5. At a low temperature, it forms diethyl ether. At 350 degrees centigrade temperature, it forms ethylene. So here, with concentrated sulfuric acid 170, with alumina at 350, it forms the same product, CH2 double bond CH2. If you use phosphoric acid, so 95% of phosphoric acid is required. If you use phosphoric acid, it is the primary alcohol. If you use 95% of phosphoric acid and at 170 degrees centigrade temperature, it forms ethylene. Okay, so phosphoric acid, so at 170 degrees centigrade, it forms ethylene. So these are the examples of dehydration of alcohol. The next, suppose in this dehydration reaction, more than one compounds or products are possible. Then which is the major product? Which is the major product? How to identify which is the major product? If two or more products are possible, then which is the major product? It is the major product. Okay, example. Complete na? Example. One or more dehydrating products are possible. Among these two, only one is the major product. Example, CH3. It is a CH. It is a OH. Next, it is a CH. It is a CH3. It is a CH3. The next two, it is a CH3. So what is the IUPAC name? It is the first carbon. It is the second carbon because of OH is the functional group. It is the third carbon. It is the fourth carbon. So first write the name of the substituent. So 3-methyl. 3-methyl. Total number of carbon atoms 4. So root word bio. Carbon containing single bond. ANE. This is replaced by alcohol. Mention the position. This OL group present at second position or present on second carbon. So on heating with the sulfuric acid. 3-methyl butane 2-ol on heating with sulfuric acid. Heating with sulfuric acid. Heating with sulfuric acid. Here two compounds or two products are possible. What are the possible compounds? What are the possible products here? So what are the possible products? Sulfuric acid is the dehydrating agent. Sulfuric acid is the dehydrating agent. So on heating with sulfuric acid H2SO4 concentrated sulfuric acid. Concentrated sulfuric acid. It forms A. It is considered as a major product. B. It is the minor product. The percentage of major product is nearly 80%. The percentage of minor product is nearly 20%. So what are A and B? What are A and B? Okay. So A is the major product. So A is CH3. Next it is CH. It is a double bond. Next it is C. It is attached with CH3. Next it is attached with CH3. The next it is CH3. So dehydration means this hydrogen and this OH. So water is eliminated here, pi bond is formed. It is the first possibility. So now it is considered as the first carbon because of substituent gets least number. It is the second carbon. It is the third carbon. It is the fourth carbon. So what is the name of A? IUPAC's name? 2-methyl butadiene or 2-butane. 2-methyl 2-butane. It is the second carbon attached with the methyl group. It is the position of double bond. So 2-methyl 2-butane. It is a major product. Nearly 80% of this product is. What is the another possibility? Suppose this OH and this H. This OH and this H are involved in dehydration. So if it loses one H plus ion, so it is CH2. It is a CH2. Now here double bond is formed. Next it is a CH. Next it is a CH. It is attached with the CH3. Next it is a CH. So now numbering is given from left hand side because of double bond is a functional group. It is the second carbon. It is the third carbon. It is the fourth carbon. So 3-methyl butadiene or 1-butane. It is 2-methyl butadiene or 2-butane. 2-methyl 2-butane. It is 3-methyl 1-butane. It is the major product. A is the major product. Percentage is 80%. So B it forms only 20%. Okay, so these are the possible compounds. So here the major product form according to Sedgwick rule. Here we should follow the Sedgwick rule. Here we should follow the Sedgwick rule. So according to Sedgwick rule. Okay, so first write the products. It is the first possibility. This OH and this H are involved in dehydration. So pi bond is formed here. Then 2-methyl 2-butane is formed or butadiene is formed. This OH, this H are involved in a dehydration reaction. So this product is formed. It is a major product. So to identify so what is the major product here? Major product formed according to Sedgwick rule. According to Sedgwick rule, it is a major product. So major product formed according to Sedgwick rule. So what is the Sedgwick rule? What is the Sedgwick rule? So according to Sedgwick rule, So alkane with more number of alkyl groups is formed. According to this set of rule, alkane means a double bonded compound. Alkane with more number of alkyl groups. More number of alkyl groups is formed. More number of alkyl groups. More number of alkyl groups is formed. These are major products. Okay. So according to Sedgwick rule, alkene with more number of alkyl groups is the major product. Is the major product. Is the major product. It is the major product. Means here these two are double bonded carbons. It is double bonded carbon. Okay. So double bonded carbon. Alkene with more number. Alkene means double bonded. So alkene with more number of alkyl groups. So this double bonded carbon is attached with CH3. This double bonded carbon is attached with 2 methyl group. So alkene with more number of alkyl groups. It contains more number of alkyl groups. It is the major product. Take the second compound. These two are double bonded carbons. These two are double bonded carbons. First carbon has no alkyl group. It is attached with 2 hydrogens. But this double bonded carbon is attached with the methyl. It is attached with the 2 hydrogens. This double bonded carbon, here it is attached with the 2 carbons. It is attached with, we consider only this carbon atom. So it is attached with the 1 carbon. It is attached with the 2 hydrogens. Whereas in first compound, this double bonded carbon is attached with 1 methyl group, 1 hydrogen. This double bonded carbon is attached with the 2 methyl groups. So according to Sedgwick rule, alkene with more number of alkyl groups is the major product. Major product. So these are the 2 possibilities. First possibility. So this OH and this H are involved in a dehydration reaction. Pi bond is formed here. It is the first possibility. The first possibility. Second possibility. This OH and out of these 3 hydrogens, 1 hydrogen involved in H plus in the form of H plus involved in dehydration. Now pi bond is formed here. So here this double bonded carbon attached with 2 hydrogens, no alkyl group. Okay, here it is attached with alkyl group. So according to Sedgwick rule, alkene with more number of alkyl groups is the major product. Here A, first product is attached with more number of alkyl groups. It is attached with more number of alkyl groups. Hence it is the major product. So second one, so these double bonded carbon atoms are attached with less number of alkyl groups. Hence it is the minor product. Okay, so Sedgwick rule is very important. So in these dehydration reactions, if 2 products are possible, so which is the major product? How to know which is the major product? Here we should follow the Sedgwick rule. So according to Sedgwick rule, what is the major product? Alkene with more number of alkyl groups is the major product. So A is the major product. Okay, so these are the applications of dehydration of alcohols. Dehydration of alcohols. Okay, the next one. So these are all examples for dehydration. It is the secondary alcohol, dehydration of alcohols. So if 2 compounds are possible, here we follow the Sedgwick rule. According to Sedgwick rule, so alkene with more number of alkyl groups is the major product. Next one. Suppose you take secondary alcohol. So secondary alcohol CH3, CHOH, CH3 is the secondary alcohol. It is the secondary alcohol. It is common name is isopropyl alcohol. What is the common name? Isopropyl alcohol. What is the IUPAC name? IUPAC name. So IUPAC name is 1, 2, 3 carbons. OH group is attached with the second carbon. So what is the IUPAC name? propan to wall. It is the UPSC name. It is the example for secondary alcohol. So if you use phosphoric acid, so secondary alcohol required 85% of phosphoric acid H3PO4. Secondary alcohol required 85% of phosphoric acid, and it required nearly 85%, and it required nearly 170 degrees centigrade. Okay. If you take tertiary alcohol, CH3, C, it is CH3. Next it is CH3. Next it is OH. So common name is tertiary butyl alcohol. 1, 2, 3, 4 carbons. So common name is tertiary butyl alcohol. Tertiary butyl alcohol. It is tertiary. So on heating with the phosphoric acid, so it required nearly 20% of phosphoric acid because of this more reactive. So it required 20% of phosphoric acid H3PO4 and half of the temperature, that is 85 degrees centigrade temperature. So here only one product is possible. This H and this OH is one propane or propane. This OH and this H is also forms propane. Here only one product is possible, that is propane. CH3, CH double bond, CH2. It is called propane. Next. When tertiary butyl alcohol on heating with dehydration reaction, so water is a byproduct. When tertiary butyl alcohol on heating with 20% of phosphoric acid, so this OH and this H, or this OH and this H, or this OH and this H is eliminated. Suppose this OH and this H are eliminated. So here the product formed is, it is a CH3, it is a C, it is a CH3. This OH and this H is eliminated. Now pi bond is found here. So common name is So common name is isobutene. What is the common name? Isobutene. 1, 2, 3, 4 carbons. Carbon contain double bond. So isobutene is in the form of iso. So it is called isobutene. So these are the dehydration reactions of alcohols. It is a very important property. So alcohols, what are the common dehydrating agents? Sulfuric acid, it is the powerful dehydrating agent. Instead of sulfuric acid, we also use phosphoric acid H3PO4. Next, alumina is also acts as a dehydrating agent. Next, phosphorus pentoxide P4 moten is also dehydrating agent. But in the dehydration of alcohols, here we use only sulfuric acid, phosphoric acid, and alumina. Okay, na? So mechanism is also important. So dehydration of primary alcohols, dehydration of secondary alcohols, dehydration of tertiary alcohols. Suppose in this dehydration reaction, more than 2 compounds are possible. More than 2 compounds are possible. So here we should follow the Sedgwick rule. According to Sedgwick rule, so alkene with more number of alkyl groups is the major product. Okay, right. The next one, oxidation properties of alcohols. Oxidation properties. Next one, dehydrogenation means elimination of hydrogen. And the last property, action with iodine, that is iodoform reaction. Formation of iodoform. So only remaining reactions are only 3 reactions are. Remaining reactions are only 3. So remaining 3 reactions I will complete in the next class. Okay. So answer the exercise 1, some bits from exercise 1. Exercise 1. Exercise 1. PCMB material. So in PCMC or PCMB, exercise 1, bits are same, but serial numbering is different. Okay, numbering is different. So here I will explain all of the difficult bits. Second one, what is the common name of 2-methyl 1-propanol? 2-methyl. What is the common name of? Exercise 1, second page. So what is the common name of? 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 So 2-methyl 2-propanol. 2-methyl 2-methyl 2-propanol. 2-methyl 2-propanol. So what is the common name of 2-methyl 2-propanol? First write the structure of 2-methyl 2-propanol. Propanol means it contains 3 carbons. It is attached with OH group. It is the second. It contains only 3 carbons, so it is the second carbon. It is 2-methyl. Next to 2-propanol. 2-methyl 2-propanol. So carbon is a tetravalent, we know. So here middle carbon tetravalence of carbon is satisfied. It required 3 hydrogens. Here valency of this carbon is 1. It is also required 3 hydrogens. It is the structure of 2-methyl 2-propanol. What is the common name? It contains how many carbons? 1, 2, 3, 4. Means butyl. Butyl. Okay. OH group is attached with tertiary carbon. Because of this carbon is attached with another 3 carbon atoms. So what is the common name? Tertiary butyl alcohol. So what is the common name of 2-methyl 2-propanol? Tertiary butyl alcohol. Or what is the IUPAC name of tertiary butyl alcohol? So it is the tertiary butyl alcohol. IUPAC name of tertiary butyl alcohol is 2-methyl 2-propanol. 2-methyl 2-propanol. Next to third one. An isomer of ethanol is isomer of third. Isomer of ethanol. Ethanol. So ethanol means ethyl alcohol. Ethyl alcohol formula CH3CH2OH. The functional isomer of alcohol is functional isomer of alcohol. Functional isomer of alcohol is ether. So write the possible ether with 2 carbons. CH3OCH3. Common name is dimethyl ether. Dimethyl ether. So what is the isomer? Ethyl alcohol has only one possible isomer, that is functional isomer. Functional isomer of alcohol is ether. So with 2 carbon atoms, possible ether is dimethyl ether. Common name is dimethyl ether. IUPAC name is methoxymethane. IUPAC name methoxymethane. The next, take the fourth one. So each of the following is a secondary alcohol. Each of the following is a secondary alcohol. Each of the following is a secondary alcohol. So first option is 2-methyl 1-propanol. 2-methyl 1-propanol. 2-methyl 1-propanol. Okay. First write the structure of 2-methyl 1-propanol. Propan means total number of carbons 3. First carbon, second carbon, third carbon. Carbon containing sigma bond. 1-propanol means first carbon is attached with OH. 2-methyl means second carbon is attached with CH3. So it required 3 hydrogens. 1, 2, 3. So trivalency. So it required 1 hydrogen to satisfy the tetravalency. It has 2 bonds. So this carbon required 2 hydrogens. Here OH group is attached with this carbon. This carbon is attached with only this carbon. So it is the primary alcohol, but not the secondary alcohol. So first option is wrong. First one is primary alcohol, but not secondary alcohol. Next, what is the second option? 2-methyl 2-propanol. Second option, 2-methyl 2-propanol. 2-methyl 2-propanol. Propan means 3 carbons. 1, 2, 3 carbons. It is the first carbon, it is the second carbon. Or it is the first carbon, it is the second carbon. 2-methyl 2-propanol. It required 3 hydrogens. It required 3 hydrogens. So 2-methyl 2-propanol means OH group is attached with this carbon. This carbon is attached with another 3 carbon atoms. So it is tertiary alcohol but not the secondary alcohol. So 2-methyl 2-propanol is common name is tertiary butyl alcohol. Common name is tertiary butyl alcohol. So it is a tertiary alcohol but not secondary alcohol. Here we require the secondary alcohol. Next, the third option, 2-butanol. What is the third option? 2-butanol. But indicates total number of carbons 4. Okay, na? So total number of carbon atoms 4. First carbon, second carbon, third carbon, fourth carbon. Let it is the first carbon. It is the second carbon OH, OL. Next, this carbon required 3 hydrogens. This carbon required only 1 hydrogen. This carbon required 2 hydrogens. This carbon required 3 hydrogens. Tetravalency of each carbon is satisfied. Here, this OH group is attached with this carbon, second carbon. It is attached with another 2 carbons. So it is a secondary alcohol. So third option is correct. What is the fourth option? 1-butanol. 1-butanol. Total number of carbons 4. 1-butanol means OH is attached with the first carbon. So this first carbon is attached with only this carbon. Only this carbon. So it is the primary alcohol. So first option is primary alcohol. Second option is tertiary alcohol. Third option is secondary alcohol. Fourth option is primary alcohol. So here we require a secondary alcohol among these 4. What is the secondary alcohol? 2-butanol is the secondary alcohol. Next. Next number. Question number 5. If the boiling point of ethyl alcohol, C2H5OH molecular weight is also mentioned. Molecular weight of ethyl alcohol is 46. So boiling point, its a boiling point is given 78 degrees centigrade. The boiling point of diethyl ether is the boiling point of diether. What is the boiling point of diethyl ether? C2H5O, C2H5. Your molecular weight of diethyl ether is 74. Molecular weight, as the molecular weight increases, boiling point increases, but it is not alcohol, it is ether. So ethers having low boiling point than alcohols because of their intermolecular hydrogen bonds are possible. It is ethyl alcohol. Due to the formation of intermolecular hydrogen bond, molecular association takes place. Hence, alcohols having higher boiling points than hydrocarbons, ethers, aldehydes, and ketones. Because of due to the formation of intermolecular hydrogen bond, molecular association takes place. That is the reason. So ether means it has a less boiling point than alcohol. So alcohol boiling point is 78 means answer is less than 78 is correct. First option is 100, greater than 78, it is wrong. Second option is 78, equal to ethyl alcohol, it is wrong. Third option 86, more than 78, alcohol. So higher than alcohol boiling point. So third option is also wrong. What is the fourth option? 34. So ethers having less boiling points than alcohol. So because of alcohols having intermolecular hydrogen bond. So less than 78. Only one option has a less than 78 degrees centigrade. Next, the seventh one, assertion reason. For a reduction of esters in 2 alcohols, so nickel in hydrogenation in presence of nickel is preferred than lithium aluminum hydride. CH3COO C2H5 on reduction in presence of lithium aluminum hydride, it gives 2 moles of ethyl alcohol. CH3 CH2OH. Instead of lithium aluminum hydride, we also use nickel, hydrogenation of nickel in presence of. So hydrogenation of nickel. So here also 2 moles of ethyl alcohol is found, which is preferable. So hydrogenation in presence of nickel is preferable because of, so with lithium aluminum hydride, so this reagent is a costly reagent, means highly expensive. Hence, so both the end we are correct and correct explanation. Next, eighth one, glucose is converted to ethyl alcohol by glucose and fructose are converted. Glucose and fructose. Glucose and fructose are converted into ethyl alcohol by the action of zymase enzyme. By the action of zymase enzyme, it gives ethyl alcohol and it loses 2 moles of carbon dioxide. So by the action of zymase enzyme, by the action of invertase enzyme, sugar is converted into glucose and fructose. So by the action of invertase enzyme, so sugar is C12H22O11 is split up into glucose and fructose. So glucose and fructose, by the action of zymase enzyme, glucose and fructose are converted to ethyl alcohol. So this process is called fermentation. What is fermentation? So complex organic compounds are decomposes to simple organic compounds by the action of enzymes. It is called fermentation reaction. Okay. So answer the remaining bits. So ninth one actually it is out of syllabus. So rectified spirit can be converted into absolute alcohol. Rectified spirit means it contains 95 nearly 6%, 95% of ethyl alcohol. So it contains nearly 4.4% of water. It is called rectified spirit. It's also azeotropic mixture, means stable boiling point. So removal of this 4.4% of water is very difficult. Hence we use suitable dehydrating agent, that is calcium oxide. Here calcium oxide is the suitable dehydrating agent. So it can absorb this 4.4% of water. Then 100% of ethyl alcohol is obtained. So it is called 100% of ethyl alcohol is called absolute alcohol. So calcium chloride is also CaCl2 is also dehydrating agent, but calcium chloride cannot be used because of calcium chloride can form additional compound CaCl2 2C2H5OH. It can form additional compound. Hence calcium chloride cannot be used. Okay. So in the next class we will start the remaining properties, oxidation properties, and dehydrogenation properties, and the last property, iodoform test and identification tests for primary, secondary, tertiary alcohols. Okay, thank you.